In this video, I want to take a look at the different ways that we graph data. We'll look at both the qualitative or categorical data, and we will look at the quantitative data as well. And what we're going to do is we're going to start with the categorical data. And you may recall there are two main ways of graphing data: bar graphs and pie charts. This is when I probably should mention to you that the beginning material in any statistics class is not overly difficult. If you run into trouble with pie charts this semester, it is going to be an extremely long semester for you because it's pretty simple stuff, folks. So let's not try to make it more difficult than it needs to be. Bar lengths, how long or short a bar. You can have horizontal bar graphs. You can have vertical bar graphs. You can turn them any way you want on the graph. We'll see some examples in a second. But the longer the bar, the more occurrences. There are two words that you should probably get comfortable with, and there's a lot of different variations of the words, but the typical words are frequency and relative frequency. Frequency refers to the number of occurrences, the number of people that said this or said that, the number that had this characteristic or that characteristic. The relative frequency, a couple other names for that, proportion or percentage of the total. And so sometimes it's advantageous to look at a graph that has one or the other, either the frequency or the relative frequency, the numbers of the percentages. But if you don't have that particular graph, it's usually pretty easy to transition between them. If you know the sample size, for instance, if you know that 40 of 200 people had a certain characteristic, well, that's 20%. So the frequency would be 40, the relative frequency would be 0.2. So that's how those things work. So bar graphs, the bar length grows based on the frequency or the relative frequency. The pie chart, how big or narrow a slice is. Think about a pizza pie. And bigger slices, higher percentages. Bigger slices, higher numbers as well. So let's take a look at a couple of examples. And I think this is going to be pretty straightforward. So in this particular example, I asked a class of students, and it was actually the class that you're taking right now. It's this Stat 2 class. I asked them, what year in school are you? I didn't have any freshmen in the class, so that's why you don't see freshmen here. Some were juniors. Some said they didn't categorize the way I wanted them to, so they called themselves others. Maybe they were returning back to school. Some were seniors, some were sophomores. Now, most of the time when you see plots like this or graphs like this, you would think it'd be sophomore, junior, senior, other. Why is it looking this way? Well, the software I used, which is the same software you're going to use, likes to alphabetize things. So because alphabetically J comes before O and an SE comes before SO, that's why the bars were listed in this order. The statistics software will do that, and it's just something you have to get used to. Here's some things that I want you to be able to do with graphs. I don't want you to spend any time drawing these graphs. Some of you may have had to do that in the Stat 1 class. Again, I apologize for that. We're going to let the computer do the drawing of the graph. You need to be able to answer basic questions. So if I ask you, in my class, which group occurred most often, you should be able to look at this and say, I have more juniors than anything else. What was the second most prevalent? Well, seniors. And sophomores, and the least prevalent were the others. Now, if I ask you a question, how many juniors are in the class? I'm looking up here, and you got to come over here and try to figure out what that is. Is that 48? Is that 49? Kind of tough to tell. So if I ask you that question, I have to make sure I ask fair questions. So I might ask, how many juniors are there? And I might say, as the answers, there's going to be, let's say, 48, 40, 10, all. That's a fair question. Now, an unfair question would be, how many juniors? And the answer is 47, 48, 49, or 50, because it's really kind of tough to tell with this particular graph. And so keep in mind, there are certain things you will be able to see, but some of the finer details you won't be able to see. So that's a good example of a bar graph. It's a frequency bar graph. I have an option where I can actually ask for the relative frequency. Now, I don't have a slide of that, but when I ask for the tattoos, I ask the students, do you have a tattoo or not? One of the examples that I look at. And in this particular class, I asked in this case for the relative frequencies. 26% said they had a tattoo. I would call this a statistic because this is a number associated with my sample. And if 26% said yes, 74% said no. If this was based on a sample of 100 students, you could easily make this 26 of the 100 said yes, 74 of the 100 said no. Now, I don't think there were 100 in this particular sample. I think it was closer to 90. We may see that in another slide. But that's how you would transition back and forth between the frequency and the relative frequency. So that's a good example of a pie chart. If in another sample I had 50% that said yes and 50% that would say no, this slice that you see right here, this 26% would grow, and it would look something like this. It'd be roughly 50% in that case. So as the percentage grows, the slice grows as well. So that's a good example of a pie chart. I don't think you probably needed one, but there it is. All right, numerical descriptions of data. Well, there's a couple of, or I should say, numerical graphs of data, is a better way of saying it. There's 3 different ones I want to take a look at. We have stem and leaf displays, and if you're going to have trouble with this video at all, it's probably there. We have bar graphs again, and we have scatter plots. Now, let me mention the bar graphs here. The bar graphs here are a little different because you can have both frequency and relative frequency again, but now because you're talking about numerical data, now I'm asking you things like, what's your GPA? And your GPA, obviously you can have numbers, 3, 4, 2, somewhere in that range. Let's say your GPA is 3.2. Are you all that much different than someone whose GPA is 3.21 or 3.18? And the answer probably is no, you're not. You're pretty close. And so what happens with the bar graphs now is similar observations are grouped together and then the bars are drawn, and we'll see that in a second. Stem and leaf displays, I love this definition. Data values are broken into stems and leaves to show where the data falls. Isn't that great? If you know what a stem and leaf display is, you just said, wow, that's a great definition. And if you're not sure what a stem and leaf display is, you're looking at this saying, that's helpful. Stems, leaves, it's a stem and leaf display, Mark, that's great. But let me show you a stem and leaf display, and then we'll talk about it, and I think you're going to find out that it's pretty straightforward. Stem and leaf display is a little tricky. But once you understand how to work with it, it's usually pretty straightforward. And then the last one we're going to talk about, you may or may not have used this in your Stat 1 classes, scatter plots. We're going to be looking for relationships between variables, and a scatter plot is one helpful way of doing it. So let me show you the examples that I've included in your slides here. Let's start with the stem and leaf display. Using some student data in usually these things, the median, the mean, the maximum are all lined up. My tabs got thrown off a little bit when I copied and pasted into my PowerPoint slides here. But this is a stem and leaf plot of the GPA. And right here is where the key to understanding how to read this thing is. The 2 and the 0, and it's referring to these 2 columns right here, the stems and the leaves. And it's specifically saying, look at that observation right there. The 2 and the 0, that's referring to these guys. The 2 and the 0 you see right here is the same as the 2 and the 0 you see right here. And it's saying that 2 and the 0 represents a GPA of 2.0. And so if I look at this value here, that 7 that I just underlined, it's grouped with a 2, so that would be a 2 and a 7. That would represent a GPA of 2.7. You can see I had 3 different people who told me their GPAs were 4.00. Oh, shouldn't say that, 4.0. 3.8. I had 3 of those. 3.9. I had 2 of those. Now, if you told me your GPA was 3.81663, the software is going to round that down to 3.8. And so there's a little rounded at times, depending how people report their results. But the stem and leaf display does 2 things. The data values are broken into the stems and the leaves. So if you tell me you're a 3.3, I'm going to put you right there. And then the other thing we can do is we can get a feel for the shape. And when we look at this distribution, take a look at this thing. I'm drawing a little curve. I know we're kind of rotated 90 degrees, but when I look at this, it's a fairly symmetric distribution. It's pretty close. I would say that we have a fairly symmetric distribution. And one of the things we're going to want to know about when we talk about shapes of distribution is, what is the shape? Is it symmetric or skewed? And I'm going to be mentioning more of that on the next video lecture that you watch. So that's what a stem and leaf display is. Now, why do I say there's confusion? Because, as I'm explaining it, it seemed pretty straightforward. In fact, look here. The minimum person told me the lowest GPA was 2.04, and it shows up as a 2.0. That's that rounding I'm talking about there. Now, the confusing part for most people in a stem and leaf display is this part here. And our software refers to it as the depth, which is a really foolish name. I've never seen that name used anywhere else, but it talks about it being the depth column. And really what it is, it's not part of the stem and leaf display. It's an extra bit of information. It's a counting column. And what the depth, or what the counting is trying to do, it's trying to take a look at this first stem here and it's saying there's one observation in that first stem. And then all of a sudden you get confused. It's like, well, wait a second, it's telling you there's one here too. No, it's not. It's telling you that there's one observation total in this stem and beyond. Now, see, there's two more here, and so it's telling you now there's a total of 3 observations this way. And I know it's getting messy now. It's doing it from both directions. Look at this number here, this 8. It's telling me there are 8 observations from that stem onward. Sometimes we talk about the edges of the distribution. We call them the tails. And so this is counting in. The depth is counting in towards the middle. And some of you might remember that the middle observation is referred to as the median. And so you can see the numbers are counting in. Where's that middle observation? Where's that middle observation? It's counting in. It's got 14. It's got 26. It's got 44 now. That way. It's got 35 that way. And now it's saying, I don't know which way you want to count from. Somebody's going to put this number in parentheses. There's 12 observations here. If you want to find the middle, you figure it out. That's kind of what that depth column is doing. It's messy. It's a messy column. It's tough to explain, but once you see it, it's just helping you count. Now, if you're looking for the median or the middle observation, another great way of doing it is look it up here. And so there's a couple ways to get the information you want, but that's what this depth is really trying to do. So if I ask you, how many of the students' GPAs are less than 3.0? Well, less than 3.0 would be all of these. You could count up the individual leaves, or you can say, well, that's what this number here is trying to tell me. There's 26 over there. And so sometimes we can use that depth column, and it helps us. But typically when I think of a stem and leaf display, I'm just thinking about the information over here, the stems and the leaves. And I think I've marked this up, stem and leaf display up enough. Hopefully that's not too confusing. But you can always print out another copy of the notes, and it'll be fresh, and you can watch again if you need to. So that's a good example of a stem and leaf display. Now let's take a look at a bar graph. I asked my college students, how much student loan debt are you going to have when you graduate college? And I asked them to give the information in thousands of dollars. And the choices were between 0 and I think I capped out at 80,000. And in this particular semester, you can see what it looks like. Now, when I look at the bar graph here, I'm not seeing a symmetric curve. I'm seeing one that's extremely skewed, and I'd say it's skewed to the right. It's always skewed in the direction of the long tail. Now you can get a good feel for the shape, and obviously this bar here is the biggest bar by far. But if I ask you how many of the students have student loan debt that exceeds, say, $20,000 or is going to exceed $20,000, you're looking this way. That's a tough answer when you're looking at a bar graph, because this looks like maybe, I don't know, is that 3 or is that 4? And then this would, maybe that's 4 and that's 2 and that's 1 and that's 1 and that's 0 and that's 2 and that's 1 and that's 2 and it's 1, and you can add them up, but it gets a little tricky. And then worse yet, what if I say 15,000, which falls in the middle of this bar? Eesh, it's kind of tough to use. The stem and leaf display is typically an easier way to answer those questions. I'm aware of the types of questions you can answer and that you can't answer. You can tell me about the shape here, but in terms of specific information, it's kind of tough. So that's what a bar graph looks like when you're working with quantitative data. And then the last plot I want to show you here, and we'll finish up, is a scatter plot. And we're going to be talking about regression analysis. That's kind of the main focus of the semester. About half the class is going to be dealing with regression. And regression talks about relationships of variables. And regression, this is kind of embarrassing as a statistician to tell you, but regression got its start with a bunch of guys sitting around trying to figure out whose son is going to be taller. Think my boy's going to be taller than your boy? Yeah? How do you know? Well, they were a bunch of math geeks, and they decided, well, let's try to figure out, let's write a mathematical equation. Regression was born from such humble beginnings. But look, there's a trend here. As dads are taller, look at that trend. The heights of the students are getting taller as well. And in this particular picture, I have both male and female students. I can break it down a little bit further. And that's what we're going to be doing with the regression analysis. But the scatter plot allows us to start seeing relationships. And so it's an interesting little plot. You can actually visualize the relationships between some variables in a scatter plot. We're looking at a positively sloped relationship. As dads get taller, we're going to hypothesize their corresponding sons get taller, or children in general get taller as well. And that's what we can use a scatter plot for. So just be aware of these different types of plots. Again, don't ever draw these things. Gosh, if you spend time drawing these plots, you're wasting your time. We're going to let the computer generate the plots, and then I'll be asking you questions about them. Hopefully those are things that make sense to you, that aren't real difficult. If you have any questions, you can always post on the discussion board, or you can get hold of me. Take care.